Hi guys, welcome back. It's Kaushik here, and today I came up with a new video on data structure and algorithm in Java. And today we are going to discuss about queue data structure. So let's see what queue is. So queue is an abstract data structure, somewhat similar to stack. Unlike stack, a queue is open at both of its ends. One end is used to insert data, and we call it as enqueue, and the other is used to remove data, and we are calling it as dequeue. Queue operations may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. Here we shall try to understand the basic operations associated with queues. Those are enqueue and dequeue. As I said earlier, enqueue means adding more elements into the queue, and dequeuing is removing those elements from the queue. So let us see how it looks like in a pictorial way. In this diagram, we can see how elements are getting added into the queue from one end and moving out from the queue from another end. Queue actually follows the FIFO architecture, that is first in, first out, which means the element which was added first moves out from the queue at first. Now let's see how the algorithm is been designed for queuing and dequeuing process. So this is the pseudocode which is written for enqueuing. And guys, please note it is not a programming language which was written. It's just a pseudocode, and it's simple English just to make you friendly with the algorithm which we are following for enqueuing process. Here we can see the data is getting added into the queue, and after getting added we are doing a check over here, that is the queue full or not. If the queue is full, we will be returning an exception, and if it is not full, we will get down to the next step. And here we are incrementing the rear value to 1, and to that index we are storing the data in the queue, and we are returning the process, and we are returning an acknowledgement that the data has been added to the queue, and we are ending the process. Similarly, in the dequeue algorithm we can see it is the process when we are removing the element from the queue. So while entering into this process, again we are doing a check, that is the queue empty or not. Maybe the user might try to dequeue an element from a queue which is already empty. In that case, we should throw either an exception or return some message that that the queue is already empty, and we can't dequeue further. So after this condition is satisfied, and if the queue is not empty, we are getting into the next step over here, and here we are creating a variable called data, and we are assigning the front element of the queue to this data. And after this, we are incrementing the front index, and we are returning the front element data. So this is the pseudocode which is written for dequeue. Now let's see how a queue looks like in actual program. Let us create a class and name it my queue. Now for creating our queue data structure, we need to declare some of the class level variables. So let us create it. int front. So this will hold the index of the front element. int rear. So this is going to hold the index of the rear element. Private int size. So this is going to hold the size of the array. Capacity. So in this variable we will be storing the total capacity of our queue. and let us create the array. This is it. Now let us create our customized constructor. With this constructor we will be creating the object of our class. Let's pass the parameter size. Uh, okay, it should not be size, it is the capacity that we will be passing from the object while creating the object. So this dot capacity equal to the capacity of our parameter variable. This dot front equal to 0. This dot size equal to 0. This dot rear equal to capacity -1. This dot array equal to new int. This dot capacity, sorry, this dot capacity. So this is going to be the size of our array which we will be passing in our constructor. Let's create the enqueue method. So with this method we will be adding elements in our queue with a parameter of item, and here our signature is ready. Now in this method we will give the check if the queue is full or not. If the queue is full we have to throw one exception. So I am calling a class which I am calling a method which is not created, so Eclipse is showing me the error. Now if we are clicking on this error, so our IDE will create a template of the method, means the signature. It will create it, and inside it we will do the check. This dot size equal to this dot capacity. So if the condition is true, then we are going to throw an exception over here. So let's declare the exception in the method level. Then now throw new exception, and within it we are going to write some message. Okay, after this we are going to do the actual adding of element and other computation. So first of all we are going to modify the rear elements index. So equal to this dot rear plus 1 mod this dot capacity. So it is going to rearrange the rear index. Now after that we are going to add the element with our new rear index. This dot array, this dot rear equal to item. Yep, this is it. Now we have to increment this size of the cube. This dot size plus plus, here it goes. Now let us print the element which we are adding into the cube. So let's print it. Adding item. Now we are done with our enqueue method. Now let's proceed with our dequeue method. Dequeue throws exception. So in this method also we are going to do the empty check. If the queue is empty and we are trying to dequeue any element, our method is supposed to throw an exception. So let us call the method, and here we are having an error. So we are having a method template now ready for us. So let us return this dot size equal to 0. So if the size is equal to 0, we will be throwing an exception. Let's send let's put some message also inside this. Queue is empty. So we are done with our check. Now let's dequeue. So we will be creating a variable inside it, and we will be assigning the front element to this variable. Array this dot front. Then after doing this, we have to rearrange the index of the front element. So this dot front equal to this dot front plus 1. Let's put this inside a scope. Yeah, then modulus this dot capacity. So we have rearranged different index. Now let's decrement the size of this queue. So this dot size minus minus, and it is done. Now let us print the dequeued item. Plus item, and we can also return it. So let's return. Here you note please, this method is actually void, so it is not supposed to return anything. So after returning, we have to change the method signature also. Yeah, we have returning integer. Now let's use this enqueue and dequeue method inside a main method and check our program is working properly or not. So let's create a main method. Inside that we have to create the object of our class. Let's name it myqueue equal to new myqueue, and keep the capacity as 5. So using this object reference, we will be calling the enqueue method and pass an element. Let us pass 22. Yeah, and enqueue is throwing exception, so similarly we have to throw exception in our main method also. So let's enqueue one more element. Let's pass 3. Here goes one more element, and we'll be adding one more. And after this we are going to run our program and check if our elements are inserting into our queue or not. Now let's run it. So as you can see, the elements are inserted into the queue in order. First 22, then 3, then 55, then 75. So it is in the same sequence. Now let us dequeue the element, and we have to call the dequeue method which we have written. So let's dequeue and execute our program. So you can see 22 was removed from the queue. So 22 was the first element which was added to the queue. So let's separate our enqueue and dequeue with a line, uh, so that we can differentiate it properly. Let's copy and paste this in dequeue so that we can dequeue more elements. Let's run it. Yeah, here it goes. Now you can see 22 was added first, so while dequeuing 22 goes out first, then 3, then 55. So it is in the same sequence in which they were inserted into the queue, and in the same order it exits from the queue. So this is how queue is using the FIFO architecture, first in first out. Thank you guys for watching this video, and this is all about queue, and catch you guys later in my next video. Thank you.